Nothing too revolutionary in the video today, as we are talking about tilesets, which is a fairly common concept in games. There are two main ways to create levels in a game. You can fully design them, or you can use a tileset to piece them together. Obviously, there are other ways, such as computer generation, which games like Minecraft and the upcoming No Man's Sky use, but these are much rarer to see in games, as they take a lot more work to make it fun. The big AAA blockbusters will sometimes use fully designed levels, so that their designers have complete control over how it looks. Games like Call of Duty do this, and most multiplayer maps that you see in games will be designed like this, as it provides complete control over every line and angle you can see in the game. However, this technique is impractical for many games, as designing every nook and cranny would be nearly impossible by the designers. To solve this, we use something called tilesets. In brief, a tileset is simply a number of models that all fit together and can be arranged in different ways to form a level. For example, say you are building a city. You don't want to design 100 different buildings to put into the city, so you design several roofs, walls, windows and entrances, which all then are combined together to form a building. These buildings are then used as the generic buildings in your city. In a fully open world game, you'll often see a mixture of both designed areas and those built with tilesets. In a way, tilesets are a bit like the fetch 10 generic object quests, except applied to level design. However, if you can make them complex enough, and do enough interesting things with them, then you can get away with it without it feeling samey. The main reason I personally use tilesets is that I'm not a 3D designer that can create sweeping vistas, and it would simply take too long to do every level that way. Every tileset has to have rules for how everything fits together and for what the tileset can do. In my case, everything is on a single level that allows for corridors, rooms, and low sections. Along with these are a number of special pieces that are also included, such as doors and entrances. In total, my tilesets have 36 pieces in order to make it work. Making a tileset can be really time consuming and tricky, as everything needs to line up perfectly and all the rules for fitting everything together is lots of code to program. Now, to actually use this tileset, we need a level layout. In bigger games, you would manually combine all these pieces together to form your level. In my case, however, we're going to use a level layout provided by a picture, where each pixel is color coded for what should be placed there. White is a square we can move in, black is a wall. Blue are low sections, blue since I wanted to make it represent water. Grey are doors, red are monsters, yellow is loot, and green and purple are entrances and exits. See, this is already getting quite complex. For the moment, we only care if the square is black, blue, or any other colour. Using this picture as our guide, we grab the correct 3D model for each square and place it in the correct place and rotate it to the correct direction. In order to simplify this for later, we then combine all these models together into a single model that can be drawn to the screen. Now for some interesting things that I encountered along the way. Originally, each piece had its own floor and ceiling. However, soon after getting it displaying correctly, I found that the brick on the ceiling and floor would be rotated with the piece and not line up correctly with the pieces around it. To solve this, the floor and ceiling were separated so that each piece has 3 parts: the walls, the floor ceiling, and a potential water model which would go below. That brings me to the next problem. In places where I had a lower section and an upper section, I needed 2 pieces for the same tile. This also leads back to the floor ceiling problem, as if you had the floor and ceiling built into the normal model, the floor would sit above the water model. So in a way, it was lucky I picked up the floor ceiling problem earlier, or I would have encountered it here as well. That's all for this video. Stay tuned for the next one where I'll be talking about minimaps. Because of course I made minimaps before programming the collision. Thanks for watching!